for later. Hey, Gavin. Okay, 5-1. The first question I see is negative cosine of negative x plus secant x. So the first thing I want to do is simplify negative cosine of negative x. And how does that simplify? Good. And what is the rule? What kind of thing are we choosing? Good. So let's look at the rules. They're just odd even, reciprocal, algebra, Pythagorean, and quotient. Algebra is anything that's not trig. And now we chose the rule and we have to click on validate. And it let us go to the next step, so it must have liked it. Our goal is to get to tangent x times sine x. So what's a thing we can try now? Thanks, Claire. What's a thing we can try? Oh my God. Thanks, Aiden. Okay, we did one like this earlier. We've got cosine x and secant x. Can we make them look more similar?
We can do 1 over cosine.
Yeah. Yeah, excellent. So we've got negative cosine x plus 1 over cosine x. With connect math, you can do a reciprocal with lots of things, but you can't do reciprocal and quotient at the same step. So this step was reciprocal. Validate, it liked it. Now I'm going to do algebra, and I can do as much algebra as I want in one step. It allows you to do that, but it only allows you to do one thing at a time in trig. So what is the first thing I want to do? 2 things.
Common denominator.
Good. So I've got negative cosine squared x over cosine x plus 1 over cosine x. Can I do more algebra? As long as it's not trig, can I do another algebra step? I have negative cosine squared x over cosine x plus 1 over cosine x. Can I combine those fractions?
Oh, yeah, you can.
Okay.
Negative cosine x.
Yeah, and I'm getting rid of the second term, and I just put the 1 over cosine x in the front. Now I can't do any more without trig. So I'm going to select algebra. In general, you want to do as much algebra as you can in each algebra step. You can't combine algebra and trig, and you can't combine trig steps, which is frustrating. But now, what is the numerator?
1 minus cosine squared x.
And can we do anything with that?
Can we turn it into square?
Yeah. And we have cosine x in the denominator. Yay, Seth. And what is the rule that we just used?
That would be
Good. Validate. It must have liked it because it allowed it to go. Now we're almost done. What do I need to do? What's the goal? Good. So that's an algebra step. I just wrote sine squared x as sine x times sine x. That's algebra. And the very last step is to write down the goal, tangent x, sine x. And what is the rule that we used? Good. Validate, and it says your proof is complete, but unless you scroll to the bottom, check answer, you won't get credit for it. It's very frustrating. That can be frustrating. So there are, some of the quizzes have identities on them that you have to prove. But if we were doing a Connect Math exam, you wouldn't have any. We will have a couple on our exam, but you don't have to do them this way. You can do them the way we did them on the board. That's right. And you can do more than one trig step at a time and stuff like that. Let's do one more. Let's do cotangent x over cosecant x minus cosecant x over cotangent x. Well, you want to do that one? We just did it. Do you want to do it? Okay. So it's minus. So what's an algebra thing I can do? All right, well, that's not algebra. That'll be a trig step. Yeah, let's get a common denominator. Cotangent x over cosecant x will be cotangent squared x over cosecant x cotangent x. And then cosecant x over cotangent x will be cosecant squared x. And the denominator will be cosecant x cotangent x. Is there another algebra step I can do? I've got two fractions with the same denominator. Yeah, let's go ahead and write cotangent squared x minus cosecant squared x in the numerator. And that's all algebra. I can't go any farther with algebra. The next step is going to require a Pythagorean identity or changing things to sines and cosines, something. Now, what do y'all want to do? First, well, notice that we've got cotangent squared x and cosecant squared x. Do we have an identity that connects those? Yeah. What do you want to substitute? Which one? We can solve for cotangent squared x in terms of cosecant squared x, or we can solve for cosecant squared x in terms of cotangent squared x. All right, so I've got cotangent squared x minus, and cosecant squared x is 1 plus cotangent squared x. In the denominator, I still have cosecant x, cotangent x. What is the rule? And now notice that I cannot combine the cotangent squared x's. I can't do algebra at the same time as I'm doing trig. If we tried that, it would say you're wrong, which is very frustrating because you're not wrong. You just skipped a step. So what rule did we just use?
That would be. I agree.
Excellent. Now let's do algebra. What is the numerator now? Excellent. And the denominator is? And what, can we do any more with algebra? Right. In order to do anything more, we've got to use some trig. Well, what do we know about 1 over cosecant x?
Secant x. Oh, sorry, that's sin x.
Good. And what about 1 over cotangent x?
That one is tangent x.
Are those both reciprocals?
Yes.
Okay, that means that we can do this in one step. Sin x, tan x, and I need to remember the negative. And the rule is going to be reciprocal. Yay. Let's do one more. Oh, this one looks nice and horrible. So I'm looking at 2 steps for this proof. The first thing we start with is 1 plus tangent squared x over tangent x. And the final goal is to get cosine x divided by sine x minus sine cubed x. So I've got 1 plus tangent squared x in the numerator, tangent x in the denominator, and my intermediate goal is 1 over cosine x sine x. What do we know about 1 plus tangent squared x? Good. And what identity is that? Excellent. Do you see what I mean about not having to memorize these things? Some of them you just learn because you're playing with them a lot. But as long as you organize your notes, I'm happy for you to use them. Okay, can we do anything with algebra if we have secant squared x and over tangent x? That's right.
Tangent x is just sine over.
Well, eventually I think we want to do that. So secant squared is what? It's secant times secant, which will be, and secant x is what? Cosine x. So we'll have 1 over cosine squared x in the numerator. We can't replace tangent at the same step. 1 over cosine x is a reciprocal identity, but the tangent x equals sine x over cosine x is a quotient identity. It will not let you do them at the same time. Now I'm going to write 1 over cosine squared x divided by, and what was tangent?
Cosine x divided by.
Oh,
Sorry.
there it is. Excellent. And that is which kind of identity? Excellent. Oh, sorry. Validate. What? Oh, I see why. It's so frustrating. If the primary fraction bar is in the wrong place, it'll say it's wrong. So I've got 1 over, and then in the numerator, I want a fraction, and in the denominator, I want a fraction. Cosine squared x, sine x, cosine x, quotient Now it likes it. It looks the same to me, but connect math is really,
Exactly the same.
yeah, connect math is very, very particular. Now, what is the denominator in the numerator part?
So, sorry, it's cosine,
Good. And the denominator in the denominator part?
cosine x,
So what can we multiply numerator and denominator by to get rid of those?
cosine squared x.
Excellent. If you multiply 1 over cosine squared x by cosine squared x, what do you have? Good. And in the denominator, we're multiplying sine x over cosine x times cosine squared x. The intermediate step is we've got a 1 in the numerator, we've got sine x over cosine x, we're multiplying it by cosine squared x. What divides out?
Oh, the cosine x.
Good. And what do we have now in the denominator?
Oh, yeah. I think cosine.
And what is the rule that we just did? Was there any trig involved? We didn't really take a reciprocal in a trig sense. All of that was just algebra. And now we're going to do the second half.
You can't even go to the check answer part.
Right,
You complete all the validation steps. So there's really no point in the check answer.
I know. And it won't let you check the answer either. It just keeps saying you have to do more. Okay, this time we've got cosine x divided by sine x minus sine cubed x. And we want to show that whole thing is equal to 1 over cosine x sine x. What can we do? Is there anything we can do in the denominator?
I guess
If we have a minus a cubed, what would we do? Yeah, so that means factor out a sine. So we'll have sine x times 1 minus sine squared x. But I can do more algebra. Or not. It actually might be easier not to do more algebra. The thing I was thinking was I could factor 1 minus sine squared into 1 plus sine x times 1 minus sine x, but this time that wouldn't help. So let's stop with algebra there. We still have cosine x in the numerator. We still have a sine x in the denominator. But what else can we write in the denominator? Instead of 1 minus sine squared x? What? Excellent. And what rule? Excellent. And now we're basically done. And we can do it just with algebra. We have a cosine x in the numerator. We have 2 cosine x's in the denominator. Can we divide them out?
you can divide the cosine out.
And in the denominator, we've got cosine x times sine x. What rule did I just use? Excellent. Yay. Okay, I think that's all I want to do, but let's make sure that the problems are all similar to things we've done. And I think they are. I think everything that we did in class is similar to something that is in the text. Bless your heart. I'm going to stop sharing and end the meeting for